Hello, class. This is the video for section 4.5, a summary of curve sketching. So, so in this video, we're going to look at, put all those things that we learned, okay, and put it together and find and sketch a graph, just like any polynomial or a rational function, okay. There are about 8 guidelines, and since most of us later on can use calculator to sketch the graphs, here I'm going to give just one example because it has a lot of steps going into one of them, just one single example. So we're going to look at all that we go through. We have learned how to find an increasing, decreasing, getting the domain. We know how to find that, and so on and so forth. So let's go through and then we'll use example. So that's the goal for this section. All right. So in sketching a graph, given the function f of x, y is equal to f of x, okay? We can sketch it by hand. And so the first step is that we find the domain of the function. Now, if it is a polynomial, it's going to be all real numbers, but it's a rational function, then there's a way we know how to do from algebra, okay? Then you take the denominator, set it to 0, and then find all values that will not make the denominator 0. Okay, so that is one. The first step, you find the domain. The second step is where you find the intercepts. Okay, in case you have forgotten, for y-intercept, you set the x for 0 for x. Okay, and then for x-intercept, you set y to 0. So for y-intercept, you set x to 0, and for x-intercept, you set y to 0, and then find the corresponding. And then the symmetry, right? We have to know whether a function is even or it is odd. Now, if it's for an even function, if you plug in negative of x into the function, you get is equal to f of x, which is the original, then that function is even. And then if it is negative f of x, then that is odd. That means that if it's an even function, then it's going to be symmetric about the y-axis. And then if it's odd, it's symmetric about the origin. Okay, that's step C. Now D, finding the asymptotes. We have the HA. Okay, remember that's what we call it. HA is horizontal asymptotes. Now, if that is finding the limits at infinity. Okay, limit at infinity. So if you have limit as x goes toward infinity of f of x, you get a value for a, okay, whether you do the positive infinity or the negative infinity, then the line y equal to what? Y equal to L is a horizontal asymptote. Okay, now if you have a rational function, definitely remember that some functions can cross the horizontal asymptote. All right, but for polynomial function, it's not what they call it. It doesn't have an asymptote, horizontal or vertical. Okay, so it turns out that when you have this goes to infinity, then you do not have asymptotes at all, and that will happen when you have polynomial functions. Okay, but for vertical asymptotes, at least one of these should be true. Okay, one of these should be true. That means if I take the element x goes to either x goes to a plus, I have to just do one of them, or I do x go to maybe minus a plus. If you have this, then you can say that if you take the limit and you get infinity, it means that the x equal to a, in this case for the first one, is a vertical asymptote. And then if you have the other one would be x equals say negative a, would be a vertical asymptote. Now for rational functions, rational functions, right? You can set the denominator to 0 and find the values, and that will be the the vertical asymptotes. Okay, equate the denominator to 0. And after you have factored it, okay, cancel all the factors there. Okay, so we have vertical asymptote and then horizontal asymptotes. Now, if f of a is not defined, but a is an endpoint of the domain of the function, then you should compute what? F of a goes to what? A minus, okay, or the limit s goes to a plus, when whether or not this limit is what? Infinite or not, okay. And then we also have our slant asymptotes, okay. Remember, if you have the degree of, if you have something like, say, x to the fourth plus, say, x squared plus 2 divided by x cubed plus x, then because the degree is 4 and this is what? This is 3 is greater, you're going to have a slant asymptote. All right. Then E, the next step is to find intervals of increasing and decreasing, which we use the first derivative test. Okay. So use the what? The first derivative for test. You can put f prime, set it to 0, find your critical values, divide the domain into parts, and then find where f prime is positive for increasing, and then f prime is what? Negative for what? For decreasing. Okay, over those intervals. And then you find the local maximum and local minimum. So here you can use the two ways. You can use the first derivative test that we talked about, or you can use the second derivative test that we talked about. Now, once you do the previous step, increasing and decreasing, you're already using the first derivative test. So by default, you're using the first derivative test, and from there, you can tell where the critical values and where the derivative, the function has what? Local or minimum, local maximum or local minimum values. All right. Now, concavity, okay, and the inflection points, we will definitely need the second derivative test. Now, if we saw the second derivative is greater than 0, it's positive, then there is it is concave up. It is negative, it is concave forward down. And where there's a change in concavity, the direction, then there is point of inflection. Then you have all these steps together. You can plot the some intercepts. You can plot them, the maximum, minimum points, and inflection points, and its asymptotes, and then you sketch the graph. Okay, so we're going to do one example. All right, just going to do one example. That is, we have f of x. You want to use the guidelines to sketch the graph of f of x, which is a rational function. Okay, what is the domain of this? Okay, what's the domain of f of x? The domain is that you don't want the denominator to be 0. So x squared minus 4, you set it to 0. Or if you solve that, then you have what? You're going to have x is equal to plus or minus what? Plus or minus 2. All right. Now let us factor this function. It's going to be x over x plus 2, x minus 2. So that's my f of x. So my domain is going to be all real numbers except what? Plus or minus 2. So that's minus 2, union minus 2 to what? To 2. And then union what? 2 to what? Positive. So that is my domain. What's my x-intercept? So first, let's find the x-intercept. Okay, here y is equal to 0. Now this is your y. Y is the what? Is the f of x. And so if you take that, y equals that means that x over what? X plus 2, x minus 2 is equal to 0. That means that only the numerator equals 0. That's 0. Because if you cross multiply, 0 times the x plus 2 times x minus 2 is what? 0. So it means that the origin is x-intercept. What about the y-intercept? Okay, y-intercept is what? You said what, x equals 0. So it means that we have to find f of 0, and that is going to be 0 over what? Actually, we have what? Minus 4, and that is what? That is 0. Again, the intercepts, the x and y intercepts is what? The origin. The origin is what? The point 0, 0. Both x and y were intercepts. All right. So that's step A and B. Now, step 3, okay, we want to find a symmetry. All right, we have f of x is giving us what? X over x minus is s squared minus 4, right? So let's just plug in, that's my f of x. Let's find f of negative x, okay? F of minus x. So wherever I see x, I'm plugging negative x, okay? Divided by minus what? X. Okay? Minus x all squared minus what? Minus 4. So this will give me negative x over x squared minus 4. Basically, it's what? Minus what? X over x squared minus 4, which is equal to minus of what? F of x. Okay, so we have seen that this is what? F of negative x is equal to negative f of what? F of x, meaning f is odd. And it's odd means what? It is what? Symmetric about the what? Origin. So then we want to find, the next step is that we want to find the asymptotes. We want to find the vertical asymptotes and the horizontal what? Asymptotes. Okay, so first, let us find the horizontal asymptote. That is what? HA. What are my horizontal asymptote? Okay, now don't forget I have f of x is equal to what? X over x squared minus 4. Okay, so then I want to find the limit. Okay, x goes to either positive infinity or negative infinity. There's one of them. Okay, positive infinity of what? Of this, which will be x, because the denominator is what? Is the degree is what? 2. We're going to divide each term by what? A square. And so this is x squared over x squared minus 4 over what? X squared. Now the numerator will be, this will be the limit. S goes to infinity. That will be 1 over x divided by 1 minus 4 over what? X squared. Now, if you impose x going to infinity, become bigger, then 1 over x will be what? 0 over 1 minus 0. So that is equal to what? 0. Okay. Therefore, the horizontal asymptote is the line y is equal to 0, which is the same as what? The x-axis. Okay. So then let's look at the vertical asymptote. Okay. Now, I know if I set the denominator x squared to 0, it's a plus or minus, right? Okay, plus or minus 2. I know I can use that, but I'm going to use the limits that we talked about. Okay, and then to show that is what the vertical asymptote. So I know that the domain x squared cannot be what? Plus or minus 2. So from algebra, okay, algebra will say that the lines, okay, the lines x is equal to 2 and x is equal to minus 2 are my what? My vertical asymptotes. But if I use calculus, as we have learned in this class, I'll just take the limit x goes to the what? The 2, okay? Maybe 2 from what? From the right, okay? Of the function f of x. So this is the limit, okay? X goes to 2 from the right of x, okay, divided by what? X squared minus what? Minus 4. Here I want to know that just the sign of what is happening, okay? So basically we have this is equal to the limit x goes to what? 2 from the right of x over x plus 2, x minus what? 2. So what would that equal? All right. Now, if x approaching what? 2 from the right, this will be what? This will be positive, okay? And that will also be what? Be positive. And then that will be positive. So this gives me what? A positive for infinity. Telling me that the line, sorry, x is equal to 2 is what? The vertical or asymptote. Or since x cannot be what? Negative 2, I can take the negative 2 either from the left or from the right. I can do it from the right of f of x and perform a similar thing. X goes to negative 2 from the right of x over x plus 2, x minus 2. Now, if you do that, what will happen is that the numerator is negative 2, so that's going to be, this is going to be what? This is going to be negative, okay? And if I'm approaching from the left, say you are putting negative 2 from the right, meaning I'm plugging in something like what? Minus 1.9, something like that. Now, if you do that, the first term here, this will be plus, okay, but that will be what? This will be negative. Give me negative over negative, which will give you what? Positive what? Infinity. So again, the line x is equal to, okay, the line x equal to negative 2 is also what? The vertical asymptote. Okay, now remember I could have what? Just set the denominator to 0 like I did for the domain and get the answer straight away without working through this. But I wanted to show you that in certain cases we can do that easily. You have to use what? This approach, find the limits. All right, good. So we have the symmetry, we have asymptotes, okay? Then we have to find increasing and decreasing. So what do we call it? We use the what? The first derivative test. So we need to find what? F prime of what? X. Get my critical values and then approach it from there. So therefore, let's differentiate this. We have f of x, okay, and the f of x is equal to what? X over x squared minus 4, okay, x squared minus 4. Now, if I differentiate this, change quotient rule, say x squared minus 4, if you differentiate x, you get 1, minus, keep the x, if you differentiate x squared minus 4, you get 2x, all divided by x squared minus 4 and all squared. Now, if you simplify this, you have what? That will give me x squared, okay, minus 4 minus 2x squared divided by x squared minus 4 all squared. Now, equate this to 0. You have the numerator will be actually minus x squared minus 4 divided by x squared minus 4 all squared. Now, which is the same as negative x squared plus 4 over x squared minus 4 all squared. All right. Now, if you set this to 0, all right, then you only have for the numerator, which is minus x squared minus 4 equal to 0. Okay, and then when you solve for x, we are going to have for x squared equal to minus 4, which is not what? It's not real. It's going to be an imaginary number. Okay, therefore, you will say that what? It has no what? Critical value. All right, this has what? Okay, before even you conclude, we also have to check this. Okay, you have to check that f prime of x, okay, does not what exist. Okay, now if you look at it, if you take any x value there, okay, if x is 2, it is squaring. Okay, if x is 2, you're going to have what? The denominator to be 0, all right? And if it is -2, the denominator will be 0. But you know that we have vertical asymptotes, all right, at x is equal to plus or minus 2. So plus or minus 2 cannot, it can't be critical numbers. Therefore, here you say there are no critical numbers. Okay. All right. So then, do you say that when we then the function doesn't increase or decrease? Well, now notice the f prime of x is actually minus what? X squared plus 4, then divided by x squared minus 4 all squared. Now this is going to be what? It's going to be negative. The denominator will be positive no matter what, and then the numerator will be negative for all x, okay, for all x in the what? In the domain. Okay, so we will say that the function decreases on its domain. The function f decreases on what? Its domain. Now, if it decreases on its domain, it means that it decreases on which interval? From minus infinity to minus 2, union -2 to what? 2, and then union what? 2 to what? Positive infinity. So it decreases on what? Its domain. All right. Then what about local maximum, local minimum? Okay. F has what? No critical numbers. Okay, critical numbers. Therefore, we say that therefore F has no maximum or right. So it decreases on its domain, the entire domain, and then it is what has no no maximum or minimum what values. All right. So then the next step is that we should find what concavity, and that is where we have to do what? We have to find the second derivative and set it to 0 and see whether it is a change. All right. So now we know that our f prime of x is what? Is negative. Okay. X squared minus 4 divided by x squared minus 4 squared. Okay. So if we keep that, okay, this is negative of that. Okay. So then if we differentiate find the second derivative of this. Okay, we want to find the second what? Derivative of that. Okay. We keep the what? The numerator, which is what? Which is x squared minus what? Minus 4 all squared. Then times the derivative of that, which will be minus what? 2x. Then minus, or I can do this, what I'm writing. I'm going to write this, keep this as what? Minus x squared plus 4 over x squared minus 4 all squared. Okay, so the second derivative is going to be x minus 4 all squared. There's a minus there. Okay, minus right there. Times what? 2x. Then minus x squared plus 4 times 2x divided by x squared minus 4. Okay, all raised to what? All raised to 4. Because we already have what? X squared there, and then all raised to 4. Now, let's simplify that. Okay, when we simplify this, we have there is a minus there. I want to keep this minus intact. Okay, I want to keep that minus intact there, which will give me what? 2x, then x squared minus 4 all squared. Okay, the minus, if you check that side, that is going to be but I got something here wrong. That's going to be, let's go back a step backwards. This is a 2x, and then have for x squared minus 4 and what? Times 2. Yeah, that's correct. So this will give me 4x. Okay, that'll be 4x. Then I have for x squared plus 4 times x squared minus 4. So I have 2 times this and that, like that. And then divided by x squared minus 4 all raised to what? Raised to 4. Okay. So if I look at this, I can factor some fact. Okay, the common I have 4x and 2x. So let's pull out 2x from that. So this is equal to this minus there. And I pull out from the numerator, I pull out 2x, and then also x squared minus 4. Then I'll be left with what? X squared minus 4, one of them, minus 2, just 2 times what? 2 times x squared plus what? Plus 4. Okay, x squared plus 4. Then all divided by x squared minus 4 all raised to 4. Okay, so see that one, this will cancel one of this, and that will give us, there's a negative there. Okay, minus, we have what? 2, and then we have what? If we redistribute this, then in the brackets there will be x squared minus 4, and then we have what? Minus 2x squared minus what? Minus 8. Okay, and then divided by x squared minus 4 all to the third. Now that will give us minus, okay, everything there in the parentheses will be what? You have your 2x, and that will give us just minus x squared minus 12 divided by x squared minus 4 all. And so if I pull out negative again, then that is going to be what? 2x, then x squared plus what? Plus 12 over x squared minus 4 all to the third. So then if you set this to 0, f prime prime of x, if you set it to 0, okay, that gives me just the numerator to 0. We have 2x, the x squared plus what? Plus 12 equal to 0. Okay. Now, if that is equal to 0, then we're going to have what? We have just what? 2x is equal to 0, or x squared plus 12 equal to 0. This is not a real number. It's not real. It's not real. So here x is equal to what? 0. Okay, but we also know that there's what? The vertical asymptotes. And so then the partitioning is, you don't only use what? You don't only use 0, but we also have what? -2 and then what? +2, because these are vertical asymptotes there. So on this interval, we want to see what happens. Okay, as we can see, if I have this function here, okay, the numerator, everything you put it in there, you have x squared times that will depend on the 2x if it's positive, and then the numerator will also could be negative or positive, depends on the 3. So if I use -3, let me change the color. Okay, if I use -3 for this interval, and I use -1, and I use 1, and I use what? +3. Let's see what happens to this, to the f prime prime. Now, if x is -3, okay, what is the parenthesis here will be positive. This will be what? This will be negative. So negative times that is negative. And if it's -3, we are going to have for it will be negative, okay, -9. If you square it, so we get +9 minus what? -4 will be what? Will be positive. So 9 minus 4 is positive. So cubic is positive. So the denominator is what? Is positive. So everything becomes negative. Therefore, this part is what? Is negative. Now, if the x is -1, well, this is negative. This guy here will always be positive. This will be positive minus, so 1 minus 4 is negative, and that will be negative. So negative over negative, we have, that will be what? Positive. And then if it's 1, plugging into that, okay, this will be positive, that is positive. If it is 1, you get +1 minus 4, which is negative. If you cube it, you get negative. So this will be what? Negative. And then if it's 3, that will be what? That will be positive. Because the numerator will be positive, the numerator also will be positive. And so what we can say that f is concave up on which interval? From -2 to what? To 0, and what? 2 to positive what? Infinity. And then f is what? Concave down on which interval? From -infinity to -2, and then from what? 0 to what? 0 to 2. Okay, where do we have a point of inflection? We have inflection point. What is IP? Inflection point at where? We have it at inflection point. Well, it cannot be at 2. If you look at it, there should be 2, but that's a vertical asymptote. So notice that. Okay, this vertical asymptote, that's a vertical asymptote. If this were not, then they will have inflection 3 inflection points at -2, at what we call 0, and then at +2. But because -2 and then +2 are what? Vertical asymptotes, you can't have this line. All right. So the only inflection point is at what? At what? X equal to 0. Now, if x is equal to 0, what is y? Y is also 0. So the origin, the origin has a law. The origin is what? X-intercept. It is y-intercept. It is also inflection point. Okay. It's inflection point. So we have all this taken care of. Now we're going to put all together and then sketch what? Sketch the graph. Okay, sketch the graph. We have the domain, we have the vertical asymptotes, we have the horizontal asymptotes. We have where it is concave up, where is, see, the function is what? It decreases. It decreases over its entire domain. So then let's put this together and graph it, graph our function here. So I'm going to have my graph. Okay. Now I'm going to spread this out. This is I have -2. That is my vertical asymptote. and I have a positive 2, also have a vertical asymptote. Okay. Then what's my horizontal asymptote is at what? This is your y, and this is x. The x-axis is the horizontal asymptote. All right. Now, according to what we have, the function decreases over its entire domain. So we have the vertical asymptote, we have horizontal. The origin is what? It's a y-intercept. It's also x-intercept. It's also a point of what? Inflection. Okay, remember that. And then he said that it's what? It decreases over its entire domain. It decreases. But we know that between from negative infinity to 2, so negative 2, the function is what? Concave what? Concave down. Okay, we just found that it's concave down from negative infinity. So what is happening is that it's concave down and it decreases. This is concave down. All right, and then also between negative 2 and 0, it is what? Concave up. Negative 2 and 0. Actually, it's concave down on this, and also from 2, sorry, 0 to what? 0 to 2. So from 0 to 2 is also concave what? Concave down. Okay. So it's going to behave like something like this. It's concave down like this. Okay. Now it is what? Concave up. Okay. And it's also concave up from what? 2 to what? The positive what? So what is happening is that at the point at 0 is a point of inflection. Remember, that's where there's a change in what? So it is going to come like this, concave up, and then tends to be concave down after x equal to negative 2, x equal to what? Positive 2. These are my vertical asymptotes. So we have everything there. We have the x-intercept is the origin, y-intercept is the origin, the inflection point is also what? Is the origin. We have there, we have the vertical asymptotes, the horizontal axis is also the x-axis. That is the line y equal to 0. It is concave up from 2 to positive infinity, and then from negative 2 to 0. And it's concave down from negative infinity to negative 2, and from 0 to what? Positive. Okay, that gives me my graph. Okay, that is the end of it. And I hope this is helpful. I'll ask you to do an example, and that might be extra credit for you. See you soon.